Hello guys, welcome once more to another video on our YouTube channel. So in this video we continue looking at further maths paper 1 solutions. So if you're just joining us, then you have to, and you have not watched the other videos, then you have to check out the solutions to the first 30 MCQs in 4 different videos. The first video was solutions from question 1 to 6. The second video, question 6 to question 10. The third video, question 11 to question 20, I think. And then the next video now was question 20 to question 30. So in this video, we begin from question 31. Alright, so here is question 31. And basically, we are going to analyze, then I answer. Alright. The general solution to the differential equation is for A and B. For constants A and B is y equal to, so our differential equation is 4y prime minus 3y prime equal to 0. So question 31. So question 31, what is the option? So if this video appears blurred to you, try to increase your resolution power so that you should see it very clearly. So the differential equation is 4 d squared y by dx squared minus 3 dy by dx equal to 0. So how do I, that is it. How do I get the general solution? First of all, the right hand side is 0, so it is homogeneous. So the general solution is just equal to the complementary function. If the right hand side had something, then we need to find a particular integral. But since it is 0, then it is homogeneous. So we first of all start by finding the auxiliary equation. Okay, and the auxiliary equation here we have 4m squared minus 3m equal to 0. So if you factorize m, you have m into 4m minus 3 equal to 0. If you solve for m, you are going to have the two values of m equal to 0 and m equal to 3 divided by 4. Now the roots of the auxiliary equation are real and distinct, so the form of my complementary function will just be a constant e raised to the power the first value of m times x plus another constant, what am I doing, plus another constant e raised to the power the second root of m times x. So here you realize that e to the power 0 is just 1, and then you multiply with a, we just have a, then plus b e raised to the power 3 divided by 4 times x. So that is the solution. So let's go and check the option. So 31, I think it's option B, right? It's option B. So 31 is option B. Now let's go to 32. So for 32, you are asked to integrate the integral of 1 over the square root of 9 plus x squared, where k is a constant. So according to the options, we are going to try 2 different substitutions. We are going to try trigonometry and we are going to try hyperbolic. But anyways, we need to integrate 1 over the square root of 9 plus x squared. So first of all, how do I choose my substitution? To choose my substitution, I look for what is disturbing in this integral. You realize that this square root is disturbing. So if I can make what is inside the square root to become a perfect square, then I have solved my problem. Alright, so it means I need to make what is inside the square root just to be equal to a perfect square, so that when I take the square root, things now become easy to work with. So I need us to recall some trigonometry identities. Cos squared x plus sin squared x is equal to 1, and then the hyperbolic identity cos squared x minus sin squared x is equal to 1. Okay, so from here you realize that there is a positive sign here, right? Okay, so let's begin with which hyperbolic function can we use. Now you see that from this hyperbolic identity, if I look for cos squared x, okay, I'm going to get 1 plus sin squared x. Okay, Now there's a positive sign there, so it's now making sense. So this 9 here, we can write this 9 as 3 squared. Okay, we can write that 9 as 3 squared. Now trying to compare with 1 and then sine squared x, it is now going to be very easy for me to let a substitution u equal to x. We are instead letting this x. Okay, we are changing x equal to 3 sine u. Now why am I doing that? Because when I'm going to look for x squared, I'm going to have 3 squared sine squared u. This 3 squared will be factorized, and then now I'm going to be left with 3 squared times 1 plus sine squared u. But knowing that 1 plus sine squared u is cos squared u, that is a perfect square I was looking for. So if I let x be equal to sine u, just follow up if you have not understood. The x will give me 3 cos u du. Now let me come back to my integral. So this integral, that integral will just be equal to the integral. In the place of the x in the numerator, I replace it with 3 cos u du. Okay, after differentiating. Now going to the denominator, there's a 3 squared here plus. Now what is x? X is 3 sine u, but when you square x, you have 3 squared sine squared u. You see that we can now factorize the 3 squared and 3 squared. Then we are going to have 1 plus sine squared u, which is cos squared u, and the square root will definitely be giving us cos u, and the cos u will cancel. So the integral will now be easy to integrate. So this is equal to the integral of 3 cos u divided by the square root. 3 squared will be factorized. I'm going to have 1 plus sine squared u. Okay, but this 1 plus sine squared u is just cos squared u. Okay, and as knowing fully well that cos u is always positive, so we don't care about the absolute value sign that will result from the square root of cos squared u. Now the square root of 3 squared is 3, so I'm going to have the integral. In the numerator I have this, in the denominator I have the very thing. Okay, because I'm going to have the square root of 3 squared is 3, and the square root of cos squared u is cos u. Now cos u will cancel with cos u. In fact, 3 cos u will cancel with 3 cos u, and we are going to be integrating at the end of the day. At the end of the day, we are going to have the integral of du. Now when we integrate du, what do we have? We just have u. So it means that my integral here is just equal to u. Okay, plus a constant of integration k. But what is u? If my x is equal to 3 sine u, then my u, you realize that first of all divide both sides by 3 to have sine u. So what will be our u? Sine inverse of u divided by 3, then plus the constant of integration. Alright, sorry, sine inverse of x divided by 3, that is u. If I want to find u here, I'll just take sine inverse on both sides. So u is sine inverse of x divided by 3. So let's go and check if the option is there. So option C is correct. So hopefully maybe by the end of the video I'll come back to this question and so say option C. I'll try to use a trigonometry substitution to see what we are going to have. Alright, question 33. This equation represents a hyperbola if what happens? So the equation is x squared on 2 minus a. So we have x squared divided by 2 minus a plus y squared divided by a minus 5 equal to -1. So first of all, I want us to recall what a hyperbola is. So the equation of a hyperbola centered at the origin is basically x squared divided by a squared, okay, plus y squared divided by minus y squared divided by b squared is equal to 1. Here is a standard equation of a hyperbola centered at the origin. If it was a positive sign here, then we talk about an ellipse. So you realize that if you want to compare with this equation, all right, this a here and this a here are not the same. All right, what is in the denominator here represents my a squared. So if I let me put p and q so that you should not be confused. So you realize that for this man to first of all be a hyperbola, I must have a positive sign here and I must have a negative sign here. So I will try to convert, I will try to divide everything by negative. Once I divide everything by negative, I will have the negative sign here, x squared divided by 2 minus a. Then the negative sign will be attached here, minus y squared divided by a minus 5 equal to 1. Now since my general formula, the x squared carries a positive sign, then I will take this negative sign and introduce it in the denominator. So if I remove the negative sign, my denominator will just switch to a minus 2. Alright, now you see everything is now perfect. So let us see. You realize that my denominator here is positive because it is p squared. This man is also positive because it is q squared, right? No matter what p and q are, once you square them, the result is positive. So you realize that this p squared here is just the same as a minus 2, and then this q squared here is just the same as a minus 5. So you realize that all the denominators are supposed to be positive. So we have that a minus 2 has to be positive and a minus 5 also has to be positive. Now what does this mean? This means that if a minus 2 is positive, then a is greater than 2, and if a minus 5 is positive, it means a is greater than 5. If I am intersecting greater than 2 and greater than 5, then definitely the result will be greater than 5. Alright, if you intersect two things, if you are greater than 5, automatically you are greater than 2. So a greater than 2, a greater than 2 is inside, not necessarily bang, it is inside a greater than 5. Though not all the elements are there, but the intersection of greater than 2 and greater than 5 will give you a region where the answers are both greater than 2 and greater than 5 at the same time, and that region is just when you are greater than 5, because all numbers that are greater than 5 are also greater than 2, but not all numbers that are greater than 2 are greater than 5. For example, 3 is greater than 2 but not greater than 5. So our answer here is a greater than 5. So a greater than 5 is supposed to be the correct option. So let's check the answers. A greater than 5 is option Z. So option Z. Okay, let's go to question 34. So question 34 is on permutations of groups. Given that we have M 1 2 3 3 2 1 and we have N 1 2 3 2 3 1 are elements of S3, that is symmetric group of permutations of this set A 1 2 3. The composition of M and N is equal to, so we need to do M of N. So M is equal to, so these are not matrices, alright, those are not matrices. So we have 1 2 3 1 2 3 3 2 1 3 2 1, and N is equal to something similar, where rather we have 1 2 3 2 3 1. So here we have 2 3 1. Okay, so how do I do the composition of these two permutations? So if I want to do the composition M of N, we actually begin with N. Okay, so this is what I do. I basically have to write down my first elements 1 2 3 1 2 3. So what we change is just the elements in the second row. Those are the elements that we change. So let us see how to compose. Like I said, we begin with N. Now this N is basically kind of a relation. 1 is related to 2, 2 is related to 3, and 3 is related to 1. So this is what we are going to do. Like I said, we begin with n. 1 is related to 2. Okay, now 2 is related to 3. 1 is related to 2, 2 is related to 3, and then 3 is related to 1. That is for n. Okay, now how do I get the composition? So this is what I do. 1 is related to 2. Now I go to m. Okay, what is 2 related to in m? 2 is related to 2, so it means that 1 will be related to 2. Okay, again, I begin with n. 1 is related to 2, and this 2 itself in m, 2 is related to 2. So when you do the composition, 1 will be related to 2. So that is it. Now 2 is related to 3. 2 is related to 3. Now what is 3 related to in m? 3 is related to 1. So it means that 2 will be related to 1. So we come and put 1 here. Automatically this man is going to give me 3 without any doubt, but let's check. 3 is related to 1 in n. Now 1 is related to what in m? Is related to 3. So this is related to 3. It therefore means that when you do the composition, 3 will be related to 3. So that is how we do the composition. Alright, so this is 1 2 3 2 1 3. 1 2 3 2 1 3. So the option B is correct. 1 2 3 2 1 3. So that is question 34. Option B. Okay, let's go to 35. So in this video we are solving to equation 50. I don't care how lengthy the video is. 35. If the rate at which cells in a certain organism die is inversely proportional to the number n of cells present at time t, treat n as a continuous variable with k a positive constant. Which of the following equations is satisfied by n? Okay, so the rate at which cells in a certain organism die is inversely proportional to the number n of cells present at time t. So what does this mean? The rate at which organisms die. Okay, rate means we have to differentiate. What are we differentiating? We are differentiating the number of organisms with respect to time. The rate at which they die is inversely proportional, means that it is directly proportional to 1 all over, is inversely proportional or directly proportional to the inverse. Alright, so it's inversely proportional to the number n of organisms present at time t. So it's inversely proportional to 1 over n. So this just means that this just means that if you want to use the equality sign, the n by dt will be equal to now I need to introduce a constant of proportionality, which is going to be k, then divided by n. Alright, but now we need to introduce a negative sign. Why? Because the organisms are dying. Alright, if the population was increasing, then if it was a growth, then the negative sign will not be there. But since the organisms are dying, the rate at which the organisms are dying, that's why we have a negative sign. So the n by dt is equal to negative k divided by n. So option A, the n by dt equal to negative k divided by n. Alright, option A is correct. Okay, 36. Using the approximation this and the step length of 0.1, the approximate value of y when x is 1.1 given this and this when x is 1 is. Okay, so let's get the approximation. So the approximation is y of n plus 1 is approximately equal to y of n plus 2h times dy by dx at n. Now the differential equation is dy by dx equal to x plus y, if I'm not mistaken. So we need to our h is a step length 0.1. we need to find the value of y when x is 1.1, given that y is equal to 0 when x is equal to 1, and x and y satisfies this differential equation. So what am I going to do? So I'll just come here and I'll put dy by dx at n is equal to x at n plus y at n. Okay, now all we need to do is we need to just use one iteration, because when x is equal to 1, y is equal to 0. Okay, now when this just means that this is a value of x0 and this is a value of y0. Now when x is equal to x0 plus h, because x1 to get the next value of x, we just need to take the previous value of x, then we add the step length. So when x1 equal to x0 plus h, which means that we have 1 plus 0.1, which is 1.1. Now what will be the value of y1? y1 is gotten by replacing n with 0. So y1 will be equal to, replacing n with 0, we need to use approximate. So y1 will be approximately equal to y0 plus 2h times dy by dx at 0. What is y0? y0 is 0, right? Because when x was 0, when x was 1, y was equal to 0, so that is y0 plus 2 times, what is h? 0.1. Now what is dy by dx at 0 is the same as x at 0 plus y at 0, because we just need to replace n with 0. So you multiply this with x0 plus y0. Okay, but what is x0? x0 is 1. What is y0? y0 is 0. So when we add, we have 1. 2 times 0.1 is 0.2. So this approximates to 0.2. So let's go and check the options. So the answer is D, 0.2. $37. So if this question was asking us for the value of y when x was 1.2, then we need to go up to x2. All right, we need to go right up till x2. 37. Where am I going? So okay, in fact, it's that I'm just going to end at 40, then I'll continue in the next video. 37. A particle performing simple harmonic motion has a speed of v meters per second when it is 1 meter from the center of oscillation. If the period of the oscillations is √2 pi seconds and the amplitude is 3 meters, what's the value of v? So let's analyze again. This v here is when it is 1 meter from the center of oscillation. They've given us a period and the amplitude. We need to find the value of v. Okay, so since it's performing simple harmonic motion, since the particle performs simple harmonic motion, then its displacement, no, I think there's one formula like that that is relating the amplitude, the angular velocity, the displacement, and the velocity. Just that I've forgotten the formula, so I'll just try to derive it because I've forgotten. So if it is performing simple harmonic motion, then the displacement is r sine omega t, right? Because it's performing simple harmonic motion. This means that its velocity at any time t, we just have to differentiate, and when we differentiate, we get omega r cos omega t, So if I square both sides, I'll have v squared equal to omega squared r squared, then cos squared omega t. That is it. But now I know that I have omega squared. If I also square this one, I have x squared equal to r squared, then times sine squared omega t. So here I'm going to have cos squared is the same as 1 minus sine squared, right? Cos squared is the same as 1 minus sine squared omega t. Okay, so this is going to give me 1 minus what is sine squared omega t. Sine squared omega t is x squared divided by r squared. So we have x squared divided by r squared. Alright, okay, now I now remember the formula. So it therefore means that we have v squared equal to omega squared times r squared. If you multiply by 1, we have it, then minus, if you multiply with this, r squared cancels r squared, we'll be left with omega squared x squared. So we'll be left with omega squared x squared. If I factorize omega squared, we'll be left here with r squared minus x squared. This r here is the amplitude, this x here is the displacement at a particular time t. Alright, so that is v squared, and since we are considering that v is positive, so v will just be equal to, if I take the square root of omega squared, I will just have omega because it's a positive quantity. Then we have to take the square root of r squared minus x squared. I think you guys know this formula, right? Sorry that it slipped off my mind, so I had to derive it. Okay, now having this in mind, let's now go back to the equation. It has a speed of v when it is 1 meter from the center. It means that the displacement is x equal to 1 if the period is root 2 pi and the amplitude is 3. Find the value of v. So it means that my v will just be equal to, remember that omega is 2 pi divided by period. The period has been given as root 2 times pi. Okay, now we have to multiply it with the square root of, the amplitude is 3 as given in the equation, and it was at a displacement of 1 meter when the velocity was v, so we just have here 1 squared. So let me simplify here directly. 9 minus 1 is 8. Okay, and the square root of 8 is the same as 2 times root 2. Alright, so root 2 cancels with root 2 in the denominator, then pi also cancels with pi. So at the end of the day, we have 4 meters per second because this pi will cancel with this pi, and 2 times 2 is 4. Okay, so question 38. So very soon I'm ending this video, and check the next video for solutions to question 41 to question 50. So the option here is option D, because they said the value of v in meters per second is, so they just have to write the answer as 4, because I've already told you that the answer is already in meters per second. So here is D. Okay, question 38. The moments of inertia of a uniform rod of mass m and length 3l about an axis through its center and perpendicular to the rod is. So the moments of inertia, so you can just use your formula booklet, but anyways, I'll give you some standard results that I've obtained. The moments of inertia of a rod about an axis passing through the center. So about an axis passing through the center and perpendicular to the rod is just equal to ml squared divided by 12. Okay, where m is the mass of the rod, l is the length of the rod. If it is passing through one of the ends, then it's going to be ml squared divided by 3. So in this case, the mass has been given as small m and the length has been given as 3l. We have to square that 3l. So here we have m divided by 12. When I square 3l, I have 9l squared. So I have ml squared times 9 over 12, so which is ml squared times 3 will go into 9 3 times and into 12 4 times. So at the end of the day we have 3 over 4, we have 3 over 4 ml squared. Okay, 3 over 4 times ml squared. So option C is correct, 3 over 4 times ml squared. 39. A force acts on a particle giving it a displacement of this. The work done by the force is, so work done is F dot Z. So work done is equal to the force multiplied by the displacement. Okay, if the displacement was not given, we need to find the displacement. That is, we need to take the change in the position vectors of the the change in the position vector of the particle. But since they have already given us a displacement, it means that the displacement from its original position to the new position has been given. So let's just do the dot product. So we have the force 2 negative 1 1 2 negative 1 1. Now the displacement is 1 1 2 1 1 2. So the result is in joules, right? Work done by the force, the result is supposed to be in Newton meter or joules. Okay, so let's multiply. We are going to have 2 times 1 is 2, 2 minus 1 is 1, so this is 2 minus 1 plus 2. This gives us 3 joules. So option A is correct, though with the wrong unit. And finally, for this video, question 40. Which option are we going to go with? So question 40. A particle P moves with constant angular speed omega on the curve whose polar equation is this. The transverse component of its acceleration is. Okay, so we need to find the transverse component of the acceleration. I think you can check your formula booklet for that transverse component of the acceleration. I never store those things in my head, so let me just check if I can find it in a textbook beside me. Which topic is this even? Okay, motion in 2 dimensions. Transverse component of the acceleration. Where is it? Alright, so the transverse component is 2 arrow dot theta dot plus arrow theta dot dot. So we have 2 arrow dot theta dot plus arrow theta dot dot. That is it. So here we are going to have so let's find the missing quantities. Now clearly theta dot dot will give me 0, okay, because this theta dot dot is just differentiating theta dot, okay, with respect to time. But differentiating theta dot is the same as differentiating omega, because omega is theta dot. But since according to the equation we're told that the angular speed, which is omega, is constant, it therefore means we are differentiating a constant, so we need to get 0. So at the end of the day we just have that the transverse component of that acceleration is 2 arrow dot theta dot. 2 arrow dot theta dot. Okay, so I'll just replace this theta dot here anyways. Let me just keep 2 theta dot. Alright, now how do I get arrow dot? Arrow dot is the derivative of arrow with respect to time, that is the arrow by dt. But if you check the equation, you realize that this arrow was not given in terms of time, it was given in terms of theta. So we have to use a chain rule, and the chain rule will tell you that to differentiate, to find the arrow by dt, we'll find the arrow by the theta first, because arrow was given in terms of theta. Then we multiply this with the theta by dt, the theta by dt. But you know fully well that the theta by dt is theta dot, so I just have theta dot. Alright, now when this theta dot multiplies with this theta dot, we just have theta dot squared. So you can just put the theta dot squared, and then I remove the theta dot from here. Okay, so I have 2 omega squared, because theta dot is omega squared. Now what is the arrow by the theta? It means that I should differentiate arrow with respect to theta. So if I differentiate 1 with respect to theta, I get 0. If I differentiate cos theta with respect to theta, I get negative sine theta. Multiplying with this negative sign, it gives us positive sine theta. So here we have sine theta. So the result is 2 omega squared sine theta. That is a radial transverse component of the acceleration. 2 omega squared sine theta. Okay, so 2 omega squared sine theta is option C. Option C. Alright, so we have come to the end of this video. See you guys in the next episode, where we are going to complete the paper solving question 41 to question 50. Alright, make sure you subscribe and comment in the comment section. Thank you.